And I'll come back, don't worry, I'll give you a chance to draw them all. This next one is r equals 2 sine of 2 theta. And then the last one is going to be r equals 2 sine of 4 theta. And again, usually the angle's in parentheses. I don't always get a chance to put them in there, but here we go. And what I want you to look at is, number one, how many petals are there? And does that relate to anything? And number two, what is the length of the petal? And does that relate to anything? Okay, so what I was hoping you would notice, first of all, in every single case out of these 4 equations, the number preceding the trig function was a 2. What does that mean?
Length.
Length of?
Petal.
The petal. The 2 in front of the trig is the length of the petal. Look at the numbers preceding the angle, theta. That number, if it's odd, is the number of petals that you have. But if it's even, the number of petals are doubled. Meaning if there's a 2 in front of the theta, there are 4 petals. If there's a 4 in front of the theta, there are 8 petals. If there's a 10 in front of the theta, 20 petals. So let me point out one more thing. In every single case, if you look at these numbers that are in front, again, the only thing that they pertain to is the length of the petal. So if I'm looking at the length of the petal in every single case, the length of the petal here is 2 units. The length of this petal is 2 units. The length of the petals down below, this length right, oh you dirty dog. This length right here is 2, and the length here is 2. In every single case, the number that comes preceding the trig function is the length of the petal. Last set of super secret notes. There's symmetry in polar graphing. So I want to talk about the symmetry. The first kind of symmetry. Looks like this. And what I want to point out in this symmetry is that this graph could be folded over what we used to call the x-axis. What's it called now?
Polar axis.
Very good. Good job, Tristan. This is polar axis symmetry. Second kind of symmetry. Is a symmetry over what we used to call the y-axis, which is now called
The non-polar axis.
no.
R.
This is theta equals pi over 2 symmetry. The last symmetry is pole symmetry, and I usually have difficulty drawing this, so please forgive me if I botch it the first time. But I'm trying to draw something that would spin around the origin, which is right here, and not be, it could be, but not be the same as the other one, so I'm going to try my best to show you what that looks like, but I may struggle, I don't know. something like that. No, that looks bad. I think I'm going to
Oh, I think I know. Maybe.
try again. Okay, so that has neither pi over 2 symmetry nor polar axis symmetry, but you could spin it around the origin. And what that means is that in between the petals is 120 degrees in this particular drawing. And I know my drawing is not perfect, but that's what it's trying to represent. And that's called pole symmetry. And back on the little box that I highlighted in green at the beginning of our lesson, I talked about that little box, and it tells you how you can tell. But usually, visually, it's pretty easy to see in addition to that information. Okay, so number 5, first thing I'm going to ask you is, what is that? It's a rose. You know it's a rose because if it was a circle, there wouldn't be a number in front of the theta. But because there's a number in front of the theta, you know it's a rose. You know it's not a limicon because there's not a plus or minus in there anywhere. Okay, and it's not a circle because there's a number in front of the theta. I'm going to fill out the table, we're going to graph it, and then we're going to talk about the rest of the problem. So let's look down here at the table. Down at the table, if I fill in some numbers, I get 0, 3, 0, negative 3, 0, 3, this is kind of boring. 0, negative 3, 3, negative 3, and 0. What kind of graph is this? A rose. Okay, I'm going to write that down. Rose. Remember, when you get done, you should have a rose. Automatically, if I know this is a rose, as I pause here to go look back up the equation highlighted in yellow, how many petals are there on this rose? 3. How long is each petal? 3. We just learned about that in the super secret notes. That's why I taught them to you. So you can look at an equation and know exactly what it's going to look like before you graph it. So when you get to the test and you graph it and you see a limicon, because all you plotted were 4 points and you have no idea what it looks like, you're in trouble, because I've already told you what it looks like. It's a rose, 3 petals. Each petal is 3 units long. So I go down here and I start plotting some points. Rose, 3 petals, 3 units long. I plot it and I see 0, 0. Here's 1 point. I see pi over 6, 3. Here's another point. I see pi over 3, 0, biggie. Pi over 2, negative 3. And I see 5 pi over 6, 3. And that's all I really care about. Because guess what? Those are my 3 petals. Remember, it's a rose with 3 petals. So first question was, where are it? Oh my gosh, sorry. Where is the R a maximum? What does R stand for? Radius or length. What's the maximum length? 3. So I know right away that my max R is equal to 3. Because it says absolute value. So they don't care about signs, they just want to know how long it is. Where does this happen? When theta is equal to
0. Pi over 6.
Pi over 6.
5 pi over 6.
5 pi over 6.
3 pi over 2.
And 3 pi over 2. Because every other angle that you name is the exact same angle. You know what I mean? Like you're going around again and again and again and again. So those are the 3 angles. Second, it talks about where is R equal to 0? That was a little bit trickier. So I'm going to go down below and talk about that from the table. When is R 0? So R equal to 0, when does that happen? when theta is equal to 0, right? That's when the radius is 0. 0. Pi over 3. 2 pi over 3?
Yes.
Pi. 2 pi.
And wouldn't it be all the other 2 pi's with 3?
Yes. Good observation. Since there's 1 pi over 3, you can pretty much, or 2 of them already, you can pretty much know that it's going to happen at every pi over 3. And what I want to do next is actually talk about how you solve this algebraically, because I can't remember if this is on the calculator or the non-calculator portion. I think it's on the calculator, but I'm not positive. Okay, so first of all, the big question is, where is my radius equal to 0? And if we had to do this algebraically, the equation that they gave us was 3 sine of 3 theta. And I want to know when that's equal to 0. So I divide both sides by 3 to get rid of the 3 that's in front of the sine. When I divide that, I end up with the sine of 3 theta equals 0. That 3 theta confuses me. I don't like that. Do you remember when we did this when it was confusing to me earlier? Instead of calling it 3 theta, we called it
Theta.
blob.
Oh.
Right? And if I was talking about the sine of blob equal to 0, where is the sine 0?
2 pi.
2 pi
Pi.
and pi. 0, pi, 2 pi, 3 pi, 4 pi, 5 pi, 6 pi. Every multiple of pi is where the sine is equal to 0. So my answer here, if I was doing this, and let's just say I was going to use degrees to make life easy. Okay, let's say I was going to use degrees. If I was using degrees, what I would tell you is in order to talk about my sine being 0, I know that that blob would be either equal to 0 degrees or 180 degrees. You could say 0 and pi radians if you want to. Now that's normally what's going on, but this blob is not theta. The blob is 3 theta. So if I actually want to find the angle measurements, I would have to divide each of those by 3. So if I divide those by 3, really what theta is 0, because 0 divided by 3 is 0. And 180 divided by 3 is 60 degrees. Notice that this 60 degrees is the same as my pi over 3 up here. And my 0 degrees is the same as my 0 radians up here. But notice all the other things that are going on. Why is that going on? The 3 in front of my theta means that I'm going 3 times as fast. So normally, if my period is 360 degrees in degrees, if I'm going 3 times as fast, what's my period now? Close.
2 pi over 2.
So, the thing you have to be aware of is that your new period is 2 pi, or we use degrees, so 360 divided by the 3, because that 3 was what was in front of my theta. And that turns out to be 120 degrees. So if you want to find out all the other pieces, you keep going. So 0 plus 120 is 120. 120 plus 120 is 240. If I go again, I get 360, but I've already talked about 360 because that's the same as 0. Now look at the 60 degrees. 60 degrees plus 120 is 180. 180 plus 120 is 300. 300 plus 120, I'm over the full circle, I can stop. There are 6 answers. Why are there 6 answers? Because we know that in a normal 2 pi period, there are always 2 answers. And we are going 3 times as fast, so 3 times 2 is 6.